Hi all, it was just introduction part of this chapter 7. The important part of this chapter starts from this activity 1 about some chemists, how they have classified the elements. Let us see how they have classified the elements. Activity 1. Before activity 1, we have Daubernier's law of traits. This is important exam point of view. We have Daubernier's law of traits, Newland's law of octaves, and Mendeleev's periodic table. These three are important. These three tables or laws we will understand first. And the previous video was it was my first video. It was about just introduction of this chapter. We understood the title of this chapter, what is classification, what are the elements, what is meant by periodic table. We got just introduction about this chapter, and it was my first video on YouTube of this class 10. If any changes or any improvements, then I'll make it in the further videos. Definitely just go through it as an introduction part of it, and it is no more not more important in the exam point of view. Let us start with this Daubernier's law of traits. Daubernier's law of trait. A German chemist, Johann Wolfgang Daubernier, 1829, noted that there were a group of elements with three elements known as traits in each group with similar chemical properties. He tried to give a relation between the properties of elements and their atomic weights. If you just read this paragraph of statement of this Daubernier law of traits, you could not understand anything. I will explain with an example which is present in the activity 1. We have Daubernier's law of trade. Trade means three elements. It is related to three elements. Like you can see the first example here in the activity 1. In this activity, you can check this first example. Lithium. Li symbol of lithium is element name lithium. Group A element and their atomic weights. Lithium atomic weight is 7.0. Sodium atomic weight is 23.0. Potassium 39.0. If you take the average of lithium and potassium, two elements, lithium and potassium, their atomic weights are 7.0 and 39.0. Make the average of it. How to make the average of it? Average of any numbers, average of the observations, sum of the observations by number of observations. We know that 7.0 plus 39.0, that is 46 by 2. What is 46 by 2? 46 by 2, I'll write here 46 by 2. 2 ones, 2 twos, 2 threes, 23. Yeah, okay. 23 is the arithmetic mean, that is the average of this group A. He explained in this way, and second I will explain. lithium, sodium and potassium. He have selected three elements named lithium, sodium and potassium, whose atomic weights are 7, 23 and 39, that is 7.0, 23.0, 39.0. And what he did, he took the average of first and last element, that is lithium and potassium. First and last element, lithium and potassium. Here is lithium and here is potassium. He added these two and he divided it by 2. So what we got the average as 23. What we can see here, this 23, this average is same as of atomic weight of the middle element. What is atomic weight of the middle element? 23. So we got both same. So he classified. So he thought that these three elements should be kept in a group. That is, what is the group here? The group is A. He kept in the group A in the order systematic way. What is the law here? When we take the average of first and last element of this group, and we take the average of first and last element, we get the average as atomic weight of the middle element, that is 23. So he took these three elements in the same group and he arranged the three elements in the same group. In the same way, if you see here, in the same way, if you see here, second group, we select second group. Second group, which contains calcium, strontium and barium. We have three elements in this. If you take the sum of first and last element, average of first and third element, that is 40 plus 137. 40 plus 137 by 2. If you calculate it, we will get the atomic weight of the middle element, that is strontium. We don't get exact value, we get some difference in the decimals. Okay, we don't get exact 87.5. We may not get in all the cases exactly the atomic weight of the middle element. This 87.5, 137, these all are atomic weights of the element. We learned in the 9th class. But what is atomic mass number and atomic weight? Atomic number and atomic weight. Okay, these are those numbers: atomic weight and atomic mass number. Atomic number and atomic weight are the things related here. You can see here the atomic weight of calcium 40 and atomic weight of barium 137 divided by 2. Then if we calculate it, we get 177. 137 plus 40, 177 by 2, it will be 88.5. So 88.5 is not exactly the middle element's atomic weight. So it is 87.5 and here we got 88.5. So it is approximately similar approximate value we got. So what Daubigny did, he arranged these three elements like calcium, strontium and barium in the group B. In the group B he have arranged. Just a second. He arranged these three elements in the group B. In the same way, we have to calculate the atomic average of the atomic weights of chlorine and iodine, and compare it with the atomic weight of the middle element, that is bromine, and calculate the average of sulfur group D, the elements which are present in the group D, sulfur and tellurium, and compare it with the middle element which is present here, and the same way third example in the which is present in the group E, the manganese and iron. Add these two and divide it by 2 and compare it with the middle one, that is chromium. So these groups A, B, C, D and E. Calculate the arithmetic mean of the atomic weights and compare it with the middle elements which are present in these all groups A, B, C, D and E, and remaining C, D and E. Calculate the arithmetic mean of the atomic weights and enter it, write it, comment it in the comment box. Okay, I will check how many of you got the correct answer. The explanation of this activity 1, as I said, these activities are very important. Whatever I explained, it is explained here. We will read it once. I am reading here. Sorry. I'm reading here. In the first row, you will find that atomic weight of the sodium here in the first row. In the first row, that is first group A. The group A, first group, you will find atomic weight of the sodium is equal to the average of relative atomic weights of lithium and potassium. If you take the average of lithium and potassium, you will see that atomic weight of the sodium. What he said, once again I will read. It is very important to understand. If you understand an example, you can understand the statement of this law, then you can remember it easily. In the first row, you will find that atomic weight of the sodium. This is atomic weight of the sodium, that is 23 is equal to average of relative atomic weights of lithium and potassium. This 23, how we got this 23? Here we got the 23. It is a average of the atomic weights of lithium and potassium, that is 7.0 plus 39.0 by 2. Average means we have to divide it 2. We have 2 atomic weights, so we are dividing it by 2. So what we got? 23. So atomic weight of the middle element is equals to the atomic weight average of the atomic weights of first element and third element. So now, after understanding these examples and this table which is present in activity 3, now we will understand the statement of the Dobromir which is given here. I said that first of all we will understand the activity. We will take an example. So we will go through the statement once. A German chemist, here I am reading here. A German chemist, Johann Wolfgang Dobromir, 1829, noted that there were a group of elements with 3 elements known as traits in each group with similar chemical properties. See this here in this group A, these elements, all these elements, lithium, sodium, potassium, have the similar chemical properties. So he kept these three elements in a group. He tried to give a here I'm reading here. He tried to give a relationship between the properties of elements and their atomic weights. He gave the relationship between properties of elements and their atomic weights. These numbers are atomic weights. He is giving the relation between atomic weights and their properties, chemical properties. Now this is the statement. Whenever you are asked to write the Dobrunner law of trade, what is Dobrunner law of trade, what is state Dobrunner law of trade, then you have to answer this paragraph. Then you have to write this paragraph, which is, I'm going to explain now. Dobrunner stated that when elements with similar properties are taken three at a time, these first group A elements are of similar properties are taken three at a time and arranged in the ascending order of their atomic weights. See, atomic weight is 7, atomic weight is 23 and 39. Atomic weights are increasing, so they have arranged in an increasing order, ascending order of the atomic weights. Atomic weight of the middle element. So what he is saying, atomic weight of the middle element is average of first and third element. Atomic weight of the middle element is the average of the atomic weight of the first and third element. This statement is called as Dobrunner law of trades. See here, whatever I have explained in this example so far till now, this is about statement itself. For understanding a better way, for understanding the statement, I have explained these examples first, then I came to the statement so that you can understand it easily. Okay, continuation of it I'm explaining here. Can you establish the same relationship with the set of elements given in the remaining rows? Yeah, we can explain this same relationship with this remaining rows also, like this row 1, A, B, C, D. He explained about the row A, row 1 it is, and I explained about row 2 also, that is B, and I asked you to calculate the atomic weights of C, D and E. So he's asking that can we establish the same relationship? Yes, we can establish it, but not exactly, but we can get it approximately. Find the average atomic weights. I'm reading here. Find the average atomic weights of the first and third elements in each row and compare it with the atomic weights of the middle element. What do you observe? We observe that is Dobrunner attempts gave a clue that atomic weight could be correlated with the properties of elements. It made chemists look at elements in terms of groups of elements with similar chemical and physical properties. This eventually led to rigorous classification of elements and modern periodic table of elements. So what he did, after observing these all groups, he have classified. Dobrunner has classified the elements. How he said, he kept the elements like lithium, sodium, potassium. He kept these three elements with similar chemical properties in a same group. The same way, B group elements, C group elements, D group, E group elements. We have classified the elements. So, what are the limitations of the Dobrunner? Limitation means what mistakes he did, what he did not do 100%, what drawbacks of the Daubernier, what he could not explain. You will see in these limitations, very important, but limitations. In the exam point of view, you may get the question as what is Daubernier law of trades, and write the limitations of Daubernier law of trades. What is the first limitation? Means it is a negative point. Negative point of this Daubernier is not a positive one. All known elements at the time could not be arranged in this form of traits. Only these elements, only some elements, only these elements are arranged in the form of traits. This is a trait. Three elements are arranged, but all elements which are known at that time could not be arranged in the form of trait. So it is a drawback. It is a limitation of the Daubernier. Second point is all known elements. It's a second point. No, the law failed for very low mass. The law failed for very low mass or for very high mass elements. This law is not suitable for very low mass elements or very high mass elements. For example, in case of fluorine, chlorine, bromine, the atomic weight of chlorine is not an arithmetic mean of the atomic weight of fluorine and bromine. So it is not succeeded. Daubernier, not Daubernier's law of trade is not possible here. So this law failed. For example, we saw here fluorine, chlorine, and bromine. Third point is as the techniques improved for measuring atomic weights, atomic masses. That is, atomic masses means atomic weights accurately. The law was unable to remain strictly valid, as atomic weights was measuring techniques was improved accurately. They was measuring. So this law of trade was not valid. It does not remain for long time. So it is also a limitation. So here, so far, what we learned about the Daubernier law of trade, and activity 1 we have completed. In activity 1 we had some calculations. We understood about this statement by using this table 1, that is this activity table, and calculate the remaining arithmetic mean, that is C group, C, D and E, and put it in the comment box. I will check it once how many of you got the correct answer. So this is the first one, Daubernier law of trade and its limitations. If you have any doubt, ask me. Feel free to ask any doubts in the comment section, or if I have to increase my voice or any other problems technically, then comment in the comment box, please. Thank you. We will, in the next class, we will learn about this Newland's law of octave and about the Mendeleev's periodic table. Then we will see about the modern periodic table, that is long form of periodic table. This is modern periodic table. We will see in the further classes, and the same way we will complete this all topics of this chapter. So this is about Daubernier law of trades and its limitation. Thank you.